typically when I start a lecture, I will have an agenda over here on the left-hand side to give you an idea about the topics that we're going to cover during our given day. I like to do that because when I go to a talk, I like to see an agenda so that it helps me kind of follow what's going on and gives me a little bit of a map about where the talk is going. So I try and do that for you guys. So today, we're going to start with a couple of questions. Some mysteries that involve electronics that you might have thought about. There's some things that I think about, and they're mysteries that we're going to solve throughout this semester. Okay, so we'll talk about some of those. Then we'll get to grades, because grades are always one of the first things that I think about when I'm in a new class. And grades also are kind of part of my teaching philosophy, so I want to talk to you guys a bit about that. We'll talk a little bit about how we're going to learn this semester. It's really going to be focused on hands-on learning, because I think that's the most beneficial, the most efficient, and also the most enjoyable. So we'll talk a little bit more about that. We'll talk briefly about Canvas and some of the resources that are available there. And then we'll go through the syllabus that breaks down in detail all of the material that we're going to discuss this semester and a couple of other important points. Then we'll have a 10 or 15 minute break, let you guys get up, stretch, use the restroom if you need to. And then we'll come back and we'll do a safety quiz. We'll fill out the safety waiver. I'll take attendance, and if anybody needs ad slips, I will be happy to add you at that point. Okay? If you're here and you want to be in the class and you're not registered yet, I will be happy to add. Okay? So that's the basic plan for today. Any questions about that? Okay, cool. So let's start with a couple of questions, a couple of mysteries that we might solve throughout the semester that we're in here. So you guys have probably played around with oscilloscopes a little bit before. We touched on them in 302, but we didn't get into a lot of their features. So you might have wondered, how can I make more precise measurements with oscilloscopes? What are some of the other functions that are available? This is one of those things that a lot of people say during the 302 classes. Those oscilloscopes are great, but I wish that we had a whole class that was just dedicated to that. You know, one day where we could just learn all the stuff about them and figure them out, because they're a really useful tool, and we only scratch the surface in 302. Well, we get to do that. And in fact, that is the first class. We'll be learning about that on Thursday, because we're going to be using those throughout the semester. And so we want to teach you all the ins and outs of them right away so that you know how to use those tools. And we'll get a lot more practice during this semester. You might have wondered, what's a transistor? You've probably heard the word before, right? Maybe you've heard of a transistor radio. You might have heard that transistors are the building blocks, the components that make computers work, right? They're inside of chips. So you might have wondered what they are and how they work. Well, we'll talk about that this semester. What's the difference between a preamplifier and a power amplifier when in music? You may have heard those terms. We'll discuss what that is. How can I build an amplifier that plays music loud enough to make my eardrums bleed? Okay. I don't know if you've ever seen the movie This Is Spinal Tap. There's a guy, a rocker, and he says, "Oh, the amp is loud, right? It goes up to 10, but sometimes I need just that little bit extra. I want to go up to 11, right? I need it to go up to 11. So anyway, we'll show you how to build amplifiers that go up to 11. Okay.
Excellent.
How can I design my own circuit board? You've probably seen circuit boards. If you've done a soldering class, you've soldered them. We've all built the communicator kit in ET302, which is a circuit board. You might have wondered how you can make your own. Well, this semester we're going to get the chance to learn how to do that. Okay? I'll give you an example. This is a board that I designed I'll pass this around. This is a fun little jack-o'-lantern project. So this is how the board comes, and then when it gets fully populated with LEDs and components, it looks like this. And we'll have a chance for each one of you to design your own board. And by the time you're done, you should have all the files that you need. Actually send it off and have it printed if you want. Make your own real working little project like this.
Yeah.
So that'll take one class to design the circuit and then one class to design the layout. So we'll talk a little bit about that later on. And these are really cool because this is a circuit that's actually functional. You know, that you could use in an instrument or a measurement device or something like that. When you have a circuit board and you solder components into it, it will last long enough and be durable enough to actually function, right? So far, we've mostly built circuits in breadboards, which are great for prototyping, but of course, components can fall out easily and stuff like that. So if you can design your own circuit board, that is something that's really functional. You can really take all this knowledge that you have and put it to use. So I think that will be a really cool project. Yeah. So those are some of the things that I wonder about, some of the topics that we're going to be covering throughout this semester. So those are some of the things that I wonder. So now I'd like to go on and talk a little bit about grades, okay? Now that we've talked a little bit about what we're going to be learning, I'd like to talk about how we're going to do the grading. So my sincere hope is that everybody in this class will get an A, all right? Let me explain a little bit about what I mean. My philosophy for grading is that the grade you receive in the class, the grade you earn, should reflect the amount of knowledge that you have. So my hope is that each and every one of you will learn the knowledge, learn the material completely. It's my goal to present it in a way that you can learn it completely. And if you can demonstrate to me that you've learned all of the material, then you should get all of the points and earn an A. And if you can all demonstrate that to me, that's what will happen. There's no limit to the number of A's that I can give out. If everybody shows me that they've learned all of the knowledge, then you will all get A's, okay? And that's what I hope will happen. That's not the way that it works at all colleges. Some places have mandatory curving. So, only 10% of students can get an A, 20% can get a B, and then the rest can get divided out. Yeah.
What? Where everyone gets 100%.
Right. Yeah. So that other philosophy doesn't make much sense to me. So I really like the fact that here at American River, I have the ability to give out as many A's as people earn, okay? So I hope that you all learn the knowledge, you can demonstrate it to me, and then I will be able to give you all A's. That doesn't mean that the class is going to be easy, okay? Far from it. In fact, we're going to be covering a lot of material. The material is going to be challenging, and so you're going to have to work very hard in order to understand it completely. So I hope that your goal is to learn the material completely. I know that's my goal for you, and if you want to do that, I'm there to support you 100% of the way, okay? If you ever get stuck on something, come and ask me about it. I will sit with you and work with you until it's crystal clear. I can explain it in different ways. I can do demonstrations for you. I can talk about it from different perspectives. I will do whatever it takes to work with you until the material makes complete sense, okay? But it's on you to come and talk to me if you have questions, all right? There's lots of places that you can do that. If I'm going through my lecture and something isn't quite clear, you can raise your hand anytime and stop me, and I'll be happy to answer questions. And you'll be doing yourself a favor, because you'll be getting that question answered. You'll be doing me a favor, because I'll understand that something's not quite clear, and you'll also be doing a favor for your classmates, because if you have a question, I can guarantee that there's 5 or 10 other people in this class who are thinking the same thing, but just don't want to raise their hands, all right? So if you raise your hand and ask the question, you're going to be helping them out too. So please feel free to stop me anytime during my lecture, and I'd be happy to answer questions. If something is still not quite clear, you can come up to me during lab. You can raise your hands, I'll come over, and I can work with you directly on the circuit that you're building or the project that you're doing. I'd be happy to answer questions then too. If that's still not quite enough time, you can come during my office hours. I have office hours from 9 till 10 at night on Monday through Thursday. That's for you guys. I know that a lot of people who come to classes in the evening do that because they're working during the daytime. They can't come to office hours during the day. So my office hours are from 9 till 10 at night, Monday through Thursday. That's right after this class, on Tuesdays to Thursdays. So hopefully, if you have questions, that will be a time that can work for you. You can come to my office hours. We can go through the material. It will take as long as required. And I want to make sure that all of this material is clear. Okay? So I really want to be there to support you. Okay? So those are my hopes for grading. I hope that you understand the material entirely, and if you can do that, everybody gets an A. I have to say, I say this at the beginning of every class that I teach, and it hasn't happened yet that I've been able to give out A's to everyone. But I hope this is the semester that it happens. Okay. Questions about that? Yeah.
How close have you gotten?
I don't keep. I'm not sure. I'm not 100% sure, but people usually do pretty well. The other key to doing well in the class is coming to class, coming to lecture, coming to lab consistently, as much as you possibly can, all right? Because when you come to class and you come to lab, you can ask those questions. I'm right here. It's really easy. I can talk to you one-on-one. It's a really quick way to exchange information. It's very efficient. The people who have trouble are generally the people who miss a lot of classes or stop coming to classes. Because when you stop coming to classes, I'm not here, you start to get behind on your work, and a lot of the concepts that we teach build on previous concepts. So if you start missing out on a few things, then it makes it harder to learn the new things. So really coming to class and coming to lecture is probably the most important thing you can do in order to do well in this class. Okay. Questions? Okay.
Does it flash? Or does it just come on, or is it sequential?
It's supposed to flash.
Okay.
I actually made a mistake when I was designing that one, so right now it does not work.
Okay.
But the next one is going to flash.
Is this the next one then?
No, that's another board from the same batch.
Okay.
Yeah.
When you design those boards, do you order them with the components already installed, or do you order the components separately and install them yourself?
There are services that allow you to order them with the components installed, but those are generally much more expensive.
Oh, a lot? Like it's not worth it? Okay.
I mean, for a small batch like this, where you're going to do 5 or 10 for yourself and your friends,
Yeah.
It's not at all worth it. If you were going to do a big product, it might.
Okay.
So are we going to do these on the new board printer? Or no? That's different, isn't it?
So Margaret knows that we actually have a printed circuit board prototyper that we have over in the office over there. And that's really cool. The cool thing about that is that it's right here on site, so the turnaround time is a couple of hours.
Yeah.
So
if it works. They were having trouble with it.
If it works. So the files that we design can be used in that prototyper, or they can be sent out to professional board houses. And there are advantages and disadvantages to each. So the main advantage to having it done here is that it's so quick.
Yeah.
You can have it back almost immediately. There are some disadvantages though. Mainly that it doesn't put a coating on the top of the board. It doesn't put any.
And there's no through hole.
Right. There's no plating in the little holes that go through the board, and it doesn't have any silkscreen text or images on the board.
Okay.
So, it might be a good idea to run a first version here, see if it works, and then you could send off another version to a fabricator and get the through holes and the silkscreen and the coating and stuff like that. Other questions? Okay. So let's talk a little bit about how we're going to learn the material this semester. Really, we value hands-on learning because, like I mentioned before, it is, I think, efficient for you guys, and also it's, I think, fun, and it's really close to what you would be doing if you go out in industry. You'll be working with circuits and troubleshooting circuits and testing things out. So a great deal of our learning is going to be hands-on. Typically, in a given day, we'll come in, I'll do a lecture about a topic for an hour and a half or so, and then we'll take a break for 10 or 15 minutes. We'll come back and we'll do a lab where you guys actually get to build a circuit related to that topic. So a little bit of theory first, and then some hands-on learning to reinforce the theory. Okay. So that's pretty much what we did in 302. We're going to be doing the same sort of thing here. Here we're actually going to be building a lot more circuits than we did in 302. A lot of work with breadboards and testing stuff out. Yeah, a lot of work with the oscilloscopes and those other measurement devices, because again, those are the types of equipment that you will be using out in the real world. Okay. So that's a little bit about how we learn. We're going to be using Canvas throughout the semester. If you guys have been in other classes at American River, you're probably familiar with Canvas by now. So we're going to be using that again. I have passed out a syllabus and a communication policy and an accommodation statement. We'll talk about those in just a second. But you should know that if you lose your hard copies for some reason, those are all available on Canvas. We're also going to have a schedule on Canvas that shows you what topics we're covering each day and what homework is assigned for that day and what reading is assigned. Okay. This semester, we're going to be using a free online textbook. And so the Canvas page will have links to all of the reading assignments. It'll link directly to the page in the textbook where you're supposed to read. Okay, so you don't have to look it up. You can just click on the link and it'll take you right there.
Nice.
Yeah.
Thank you.
Yeah, that's awesome.
Yeah.
We know you set it up.
Yeah.
Yeah.
We did that because I know the textbooks are expensive and a lot of people struggle with that. That there is a misprint in the syllabus, and I'll cover that again in a second. The syllabus says that you have to buy a textbook from the bookstore, but that's just a typo. Like I mentioned, we're going to be using the free online textbook this semester. So that's
awesome.
Yeah. On Canvas, there is also a link to the YouTube channel where I have all of my lectures posted. Okay, so if you have to miss a day for some reason, or you want to review something, you can go to the main page of Canvas, and there's a link right there to take you right to YouTube. Okay. So any questions about Canvas?
Do you have to buy a lab book?
Yes, the lab book is required, and that's actually a great transition to the syllabus. Or we'll talk about this now, and we'll go there. So this is the lab book. It is required. It has all of the procedures for all the labs that we're going to do. It also has spaces to record the data from the labs. Now, I have just heard that the library or the bookstore is actually sold out of these at the moment. So I need to go and talk to them and get that straightened out. So I apologize for that. I don't know why that happened, but I will talk to them and get that straightened out. In the meantime, we will have printed copies of the labs that you guys can use. So we'll distribute those to you guys until they become available at the bookstore. So I apologize for that, but that's where we stand. Yeah. So other questions about the syllabus before we move on? Or I'm sorry, about Canvas before we move on to the syllabus? Okay. So this is the syllabus. You guys should all have one of these now. We're going to take a few minutes to go through it all. It's kind of boring stuff. I apologize up front, but I want to make sure that everybody is familiar with what's going on here. So the course description. This course is a detailed study of semiconductor devices and their applications. So semiconductors are mostly devices based on silicon, right? They include diodes, transistors, op-amps, and we'll talk about all of those. We'll talk about nanotechnology theory and devices, including their present and possible future applications. So when we say nanotechnology devices, really we're referring to devices with nanometer scale components. And that really includes just about any computer chip or any integrated circuit that's out there these days. So we're not going to be focusing on little tiny robots or stuff like that. We're going to be focusing, I know.
Dang it.
We're going to be focusing on chips and integrated circuits that have nanometer scale components inside them. Okay. Field trips may be required. I'm going to try and get a field trip together for you guys. Who likes field trips? Yeah! Okay, I love them. So we're going to try and get something together. It's always a little bit hard for evening classes because a lot of businesses and places are closed at night, but we'll try and get something together to see what we can do for you. All right. Student learning outcomes. These are things that you should be able to do by the time you're done with this course. So evaluate and compare the physical construction and theory of operation of junction diodes. Right? Diodes are little devices that are made out of silicon, so they're semiconductor devices. We're going to be talking a bit about those during the beginning of the class. There are different kinds. There's bipolar junction transistors, field effect transistors, and operational amplifiers as well, all semiconductor devices. Troubleshoot linear and switch mode power supplies. Power supplies are one of the most widely used circuits that are around. I mean, almost every device that you have has some sort of power supply built in. It's the circuit that takes the alternating current, comes out of the wall, and turns it into DC, direct current, that's used in most electronics. So we're going to study linear and switch mode power supplies. These are two different types. Linear is more traditional, switch mode is more efficient and newer options. So we'll learn how both of those work. Evaluate and diagnose amplifier, power supply, and driver circuit properties. Okay. So we're going to be talking a lot about amplifiers and power supplies in this class. And I don't know about you guys, but I've never built a circuit that worked exactly right the first time. So when you build these types of circuits, you will inherently see issues and problems, and you'll learn how to troubleshoot them as you go along. Okay? There's also some simulation that we do in the challenge software that deals with power supplies and troubleshooting issues with those. So we'll learn about how to do that. You will calculate the theoretical operating characteristics and compare the measured results on operating amplifier circuits. Okay? So, like I said, we're going to be talking a lot about amplifiers. This goes back to the audio amplifiers that we mentioned earlier on. We'll talk about different classes of amplifiers, some that are used to amplify voltage, some that are used to amplify current, small signals to big signals. So that'll be interesting. We'll diagram and label the functional blocks of amplifiers and power supplies. So rather than just looking at each component in a power supply, sometimes it helps to break the power supplies into functional blocks or stages. If you understand what each stage is meant to do, then it gives you insight into how everything is working together. We'll interpret schematic diagrams and formulate solutions to problems in electronic circuitry. Okay, so schematic diagrams, like I said, we'll be dealing with schematic diagrams. When you build your own circuit board, the first thing that you're going to do is make a schematic diagram that shows how everything is connected. So when you're doing that, you will be formulating a solution to a problem, namely how to make the little lights blink in electronic circuitry. And every time you build a circuit in the lab, you will be interpreting the circuit diagram, the schematic diagram, figuring out what it's saying, and then formulating a solution for an issue. So you will assess data from a variety of test and measurement equipment used in the analysis of power supply and amplifier circuits. So, like I said, we're going to get you guys using all of this test and measurement equipment ASAP so that you become familiar with it. This is the type of stuff that you will be using out in the industry. It's the state-of-the-art equipment, and so you guys get a lot of practice using that, and you'll use it to troubleshoot all your circuits, not just the amplifier and power supply ones. You'll categorize, analyze, and describe basic nanotechnology building blocks and their possible uses. So we'll look a little bit at some circuit diagrams, schematic diagrams for the inside of an op-amp, for instance. And you'll see that just like there are stages in a power supply, there are stages in integrated circuits as well. So these stages can be building blocks that can be used. If you put them together one way, you can make an amplifier. If you put them together another way, you can make other types of circuits. So we'll talk about what those stages are and how you can use them. And then you'll construct and test circuits on prototyping boards and printed circuit boards. You're going to be doing that pretty much every night, okay? You'll be doing different kinds of circuits, but you'll almost always be using prototyping boards and PCBs. Okay. So those are the student learning outcomes, the things you should be able to do at the end of the class. Any questions about those? All right. Class times are Tuesdays and Thursdays from 6 till 9, pretty much. The final is on December 20th. The professor is me, Jordan Meyer. My office is in the Tech Ed building, number 16. Has everybody been over to the Tech Ed building? Anybody who hasn't been there before? You haven't been? Okay. So I can show you where that is. Basically, it's the building. If you get to the end of this building and just keep going, it's the first one on your right. So that's where my office is. That's where the offices of all the professors are. So my office is number 16, and if you go to the front desk, they can definitely show you where that is.
I have a question. Is the final on the computer just a written final then? Or will we have a project?
I believe that the final exam will all be multiple choice questions on the computer.
Thank you.
The midterm, I think, will be part hands-on and part written. Other questions? So my office hours, I have some during the day from 12 to 12:30 on Mondays and Wednesdays, and then like I mentioned for you guys, I have office hours from 9 till 10 on Monday, Tuesday, Wednesday, and Thursday. Right? So hopefully, if you have questions, you'll be able to make one of those times. You could always email me or call me. My contact information is listed there on the page. The evaluation procedure shows how the points will be distributed for this class. You can see that the majority of your points come from labs. That's because we really value the hands-on learning approach. We think that the labs are a very important learning tool, so we put most of the points with the labs. So that's another reason why it's important to keep coming to class, so you can keep getting through that material and getting the points for the labs. There will be 4 homework assignments from the lab book. 3 points each. There'll be 3 crosswords. There will be 8 online quizzes, some challenge software, and then a midterm and a final. So those are how the points are distributed. The grades are based on the percentage of the total points that you earn. So if you get between 90 and 100%, that's an A. 80 to 90% is B, and so on and so forth. So any questions about the grading procedure? Okay. Required materials. Like I mentioned, the syllabus says that you have to buy a textbook, but that's a typo. We will be using the free online textbook this semester. I already mentioned the lab book. You do have to get the lab book that's available at the bookstore. Sold out right now, but hopefully we can get them to buy that again soon. Scientific calculator is highly recommended. If you have a calculator already and you know how to use it, that's great. If you don't have one and you need to go get one, we recommend the TI-30X2S. It's fairly inexpensive. It's about $10. It has a wide variety of functions, more than enough to do the stuff we need in this class. And it's available in many places, including a bookstore, online, and also at lots of office supply stores. So if you have one and you know how to use it, totally fine. You can use whatever you want. If you need to go buy one, that is a good one. You're not required to buy any supplies for the lab. You do need to have some safety goggles. So they don't have to be anything fancy, just standard issue safety goggles. You have some already, that's totally fine. You can use whatever you have. If you need to go buy some, they're pretty cheap. They're like $2 or $3 at the bookstore, or you can get them at any Home Depot or Lowe's or things like that. So you just need to have some sort of safety glasses that wrap around the edge. I'm sorry, I thought I saw it. They just need to wrap around the edge and protect your eyes. Reading glasses or normal glasses that you wear every day are not enough because they don't have the wraparound sides. So you need to have something specifically designed for wraparound. If you have safety goggles, those are fine too. Again, nothing fancy, no stringent requirements, just something designed specifically for safety. These are especially important in this class when we are dealing with electrolytic capacitors.
Ooh.
Anybody remember what happens if you plug one in backwards?
Let it G out.
They blow up.
Yeah, they explode like a little firecracker.
Smoke.
Yeah.
You let the smoke out, yeah.
And those are especially dangerous because they have an outer shell made out of metal. So when they pop, it sends shrapnel all over the place. And if you're wearing safety glasses, it's not a big deal. It bounces right off. It's not heavy. It's not going to hurt you. But if you are not wearing safety glasses, it can end up in your eyeball, and it's bad news. Okay. So safety glasses are important. Yeah.
I said it. But I actually had a question right there.
Oh, okay. I was just going to say we wanted to lend them out to you guys. We used to do that, but the school said that that's not acceptable anymore because it poses a health risk when we loan one pair of glasses out to lots of different people. So everybody needs to go.
About the printed circuit boards we're designing. Mm-hmm. Now, is that going to be like a certain specification to control something certain, like specific, or are we going to design it for our own needs? Like if we want to design something.
He's smiling.
So the default is to make a design that causes lights to blink. And then you would be free to arrange those lights in whatever pattern you want and make the board into whatever shape. If you have some other type of circuit in mind, we can talk about it, and if that fits within the time constraints and stuff, then that would work cool. Mm-hmm. Yeah, other questions? Okay, cool. Alright, so we've got the safety glasses. So that brings us to the communication policy. That is the the blue sheet is at the top. So the communication policy talks a little bit about how I will communicate with you and how I would like you to communicate with me. So one of the main tools that I'll use to communicate with you is Canvas. Like I mentioned already, there will be assignments posted on Canvas, your grades will be posted on Canvas, there will be quizzes that are available through Canvas, sometimes I'll make announcements that pop up on Canvas, so I highly encourage you to check that regularly, okay? At least every time that you come to class. As far as grading and feedback goes, like I said, the quizzes that are on Canvas, they will be graded automatically and you'll get to see your grades right away. Your lab books will be graded periodically. So every night when you are done with your lab, you should ask me or Andre or one of the other lab helpers to come around and check your work. And we'll look at the circuit that you've built, we'll make sure that it's working the way that we expect it to work, and then when everything looks good, we'll sign you off. Okay, so you need to get your lab work signed off every night. And then periodically, every 2 or 3 weeks, someone will come around and check your lab books and see which assignments have been done, and then upload those assignments into Canvas. Okay? So that will happen every 2 or 3 weeks. And then once those are uploaded, you'll be able to see those grades. Yeah?
Are we going to get extra credits for finding mistakes?
Yes. Yeah, thank you for bringing that up. The lab books are an ongoing project. They're a work in progress. We try to make them as good and as clear as possible, but there are always typos, mistakes, small issues that can be corrected. So, as a way to encourage you to read the text very carefully, and also as a favor to us, I will be wording points if you find typos or misprints in the book. So every time you find a typo or an error, and you tell me about it, I'll write it down and I'll give you an extra point in Canvas. Okay? So, yeah, thank you for mentioning that. Going back to the communication, midterm and final grades will also be posted in Canvas. They should be up there about a week or so after the tests happen. So, any questions about the grading and feedback? Email. Each student at ARC, that means all of you, is given a student Gmail account. And when I want to email everybody in the class, the email goes to those accounts. So it's important that you guys check those accounts. You can either go and check them directly, or you can set them up so that they forward the mail to another address, maybe a personal email address that you check anyway. But one way or another, you need to make sure that you are checking that student Gmail address on a regular basis.
You know, is there a way to forward mail from just a specific person? Because I get like junk mail from the
Right.
group.
Right.
And I always find that I forget to check my school email. So
yeah, that's a good question. I think probably. I don't know how to do it off the top of my
okay,
head.
I'll look at it. I just didn't know if it was possible.
Probably. Yeah. Other questions about the Gmail? Some things that you can do to communicate with me. You are always welcome to talk to me during class. Like I said, I'm always here. If you can't get to me during class, you can send me emails. My email address is listed there. You can give me a call on the phone. My phone number is listed there as well. And then you can always drop by my office hours and talk to me there as well. Announcements, like I mentioned, I sometimes make announcements on the Canvas page, so you can check those. There are rules of etiquette. These are online etiquette rules. Basically, it boils down to being polite and courteous with your fellow students. and treating other people the way that you would want to be treated. So I think it's pretty much common sense there, but there are rules if you want to go and read about them. And then that brings us to the accommodation statement. So that is this green sheet of paper over here. I've designed this course to be welcoming and accessible to everyone, and I hope that all of the material is available and easy for everyone to read and understand. If something is not accessible to you for any reason, please let me know, and I will try and correct that as soon as possible. Okay? If you're having an issue with it, chances are that other people are also, so please don't hesitate to let me know. There are lots of ways that I can tailor the class to meet your needs. I can give you extra time on exams, I can give you extra time to turn in homework, I can give you a seat at the front of the class, if that's good for you. I can give you a seat at the back of the class, if that's what you prefer. I can do all of these things for you, but I can only do them if they are recommended or requested by the Office of Disabled Student Programs and Services. So if you need to have an academic accommodation for some reason, then it's your responsibility to go over to the Office of DSPNS and sit down with them and discuss what types of accommodations you need. They'll do a quick assessment with you. They will they'll figure out which accommodations are appropriate for you, and then they'll write those down on a pink sheet of paper. And then you will bring the pink sheet of paper to me, and it will only have your accommodations written down. It won't have anything about any reasons that you need those accommodations. That's strictly between you and the Office of DSPNS. The pink sheet of paper will just have the accommodations that you need. And I will get it, I'll sign it, and I'll make sure that you get those accommodations as soon as possible. Okay? So if you have any of those issues, if you need to have any accommodations, by all means, go and speak with DSPNS. I cannot request those for you. That's something that you have to do for yourself. So you initiate it, you go over, talk to them, and then bring me the pink sheet of paper, and then I will make sure that that you get the accommodations that you need. Okay? The contact information is listed there on the bottom of the green sheet of paper. You can go and see them in person. You can drop in or make an appointment, and there's a phone number where you can call them to set that up as well. So, any questions about the accommodations? Okay, cool. All right, so we're back to the syllabus now. For the details, you can see that this course is transferable to Cal State system. It's also part of the AA and AS degree. There's units listed there. The electronics main web page is listed there. You can see that there are computers at each of these desks, and you can log on to those computers using your student ID and normal password. We already talked a little bit about the course format and the way that we're going to learn. We already talked a little bit about tests and quizzes. Late work. So, my philosophy is that if you do the work, you should get credit for it. Okay? Some professors say that this assignment is due on this date, and if you turn it in one day late, you get no credit. That doesn't make a lot of sense to me. I think that if you put in the effort and you finish the assignment, you should get credit for it. So my policy for homework and labs is that as long as you finish them by the end of the semester, I will give you credit for it. Okay? So there are no hard and fast deadlines for homeworks, for crosswords, for labs, for things like that. Okay? That means that if you are really sick and you need to stay home and you miss a day, it's not going to affect your grade. You just have to come in a little bit later, find a time when you can make up that work, and make sure that it gets done. Okay? You guys are all adults. I trust you to manage your own time and set your own schedules. So I will give you that leeway to manage and decide when you're going to do the work. Like I mentioned before, I strongly recommend that you come to class all the time, if you possibly can, because that's the best way to stay up with your work and make sure you don't fall behind. But I won't grade you down if you have to miss for some reason. Okay? That does put a lot of responsibility on you. I'm not going to be checking in with you every day and saying, did you do your work? Did you do your work? Are you getting caught up? Right? I'm going to leave that up to you. And so it would be possible for you to put everything off until the last week, and I'm not going to grade you down for that necessarily, but I can guarantee that if you leave everything until the last week, it's going to be a really long week for you, and you're not going to get it done. All right? So I'm putting my trust in you that you will manage your own time and stay up with work. Okay? So as far as late work goes, there won't be any grade reduction for turning the work in after a certain time. The one exception to that are the midterm and the final exams. Okay, you need to be here on the day of the midterm, and you need to be here on the day of the final. If for some reason you know that you're going to be, on a work trip, say, on the day of the midterm, and you know that ahead of time, you can come and talk to me, and we can try and work something out. But you need to talk to me ahead of time in order to do an accommodation like that. All right? So the midterm and the final are the days when you really need to be. But other than that, as long as you get it done by the end of the semester, it's okay. So questions about that? Midterm progress and final grades, like I said, we'll be updating your grades throughout the semester, and we'll be seeing those on Canvas, so you should be able to keep up with those. The attendance requirements. So the school has a policy that says if you have absences in excess of 6% of your class, then I'm supposed to drop you. Well, it works out that 6% of the class is about 2 days in a single semester, right? So technically, if you miss more than 2 days in a semester, I'm supposed to drop you. Now again, to me that seems unnecessarily harsh, okay? I know that sometimes things come up, you get really sick. I don't want you to come in here when you're really sick. It's going to be terrible for you. You're probably not going to learn anything, and you probably get your classmates sick. So I don't want that. It's not good for anybody. If you're sick, stay home, feel better, come back as soon as you can. Like I said, I trust you to find time to come in and make up the work. So if you have to be absent for more than 2 days, that's fine. I trust you to find the time to come in and make up the work that you missed. If you are absent for several days in a row, I might send you an email just checking in and saying, hey, you doing all right? Is there anything that you need? What's going on? Right? But I'm not going to drop you right away. That being said, if you are absent for 2 or 3 weeks in a row, and I send you emails and I don't hear anything back, I may end up dropping you. Okay? So if you know you're going to be out for a long time for some reason, communicate with me. Talk to me, send me an email, something. Give me a heads up about what's going on. That way I'll know, and nothing unexpected is going to happen. Okay? The flip side of that is that I'm not going to drop you automatically, even if you don't show up. So you might be going through the semester, you're doing great, and then halfway through, your work schedule changes, and you can't come to class anymore. And you figure, oh, well, I'm not coming to class, he's just going to drop me, it's going to be fine. You can't rely on that. Don't count on me to drop you. If you know you're not going to be in the class anymore, it's up to you to withdraw yourself. If you don't do that, then you stay in the class, but you just stop coming, then there's a chance that you'll just be in it until the end and you get a bad grade on your transcript because you didn't do half the work. So if you know for some reason that you can't come to class anymore, please go to e-services and withdraw yourself. Okay? So that's what I wanted to say about attendance. Any questions about that? Safety, release of liability, and waiver form. We're going to do that after the break. So we'll come back to that. Support services. There are a couple of really great support, well, there are many really great support services here on campus. A couple that I want to highlight are reading across the disciplines and writing across the curriculum. So, reading across the disciplines is this program where you get to go and they teach you strategies to read more quickly and more efficiently and take notes, and basically they teach you how to learn better. And you can apply it to this course, and you can apply it to any other course that you're going to take. You can really apply it to any type of reading that you ever do. They tailor it specifically to the type of class that you're in. So if you're in an electronics class, they will teach you how to read electronics textbooks and things like that. They won't give you extra reading assignments. They'll just have you do the reading that you're already supposed to do and teach you these strategies that you can use to do it more quickly and learn the material, absorb it more completely. Okay, so it's a great program. I took it myself actually when I came here because I was studying for the GRE test. And I can tell you firsthand, it's a great program. The strategies are real, concrete things. It's not just some, fuzzy pie in the sky thing. They teach you real. No, they teach you real strategies, like how to annotate pages to record your thoughts, and so it's a great program. So. Highly recommend it. It's a half-minute course. Basically, you go in there for an hour a week for 9 weeks, and they help you read material that you would be reading anyway, and they teach you these strategies to use. But you have to sign up for a particular time slot that works for you. So those time slots fill up quickly, so if you want to get in this program, I recommend that you go over to the Learning Resource Center and sign up with them as soon as possible. I will actually give you extra credit for being in the program. So not only will you learn the material better and quicker, but I'll give you extra points for being there too. So I highly recommend it. It's one of those things I wish I had done when I was in college, is that I could have studied more quickly and learned the material more deeply, and so that I would have had more time to go out and party, right? And that's what we're doing. So, anyway, highly recommend it. Writing across the curriculum is a really great program too. It's not as applicable to this course because it has to do with writing assignments, and we don't really assign writing assignments in this class. So, great program, but not so applicable to us. So, on the Canvas page, there are also a bunch of other student help services that are listed there, and you can check those out. In particular, we're going to have a Beacon tutoring program. Has anybody met Earl before? Yeah. So, Earl is our Beacon tutor. He's going to be with us again this semester. He's been through all these classes. He knows the material really well, and he will be there to help you free of charge during his drop-in hours. Okay? So, conduct and behavior. Basically, we want to make this a welcoming learning environment for everybody who's here. So again, this is kind of common courtesy stuff. You want to treat other people the way that you would like to be treated. It's not rocket science, it's pretty much common sense. Plagiarism and cheating. That's not tolerated in an academic environment, it's not okay. So please don't do it. There's a whole list of of the consequences that happen if you get caught plagiarizing or cheating. We don't really have issues with that. We haven't seen problems with that in our classes, but we still have to list out what happens just in case. So it's nasty. I don't want to deal with it. I'm sure you guys don't want to deal with it. So just don't go there, okay? Especially use health and safety. We already talked about the accommodation statement, so I think that covers what I wanted to say about that. Field trips. We already talked about field trips a little bit. I'm going to try and get something together for you guys. If I can find something, I'll let you know more details as they come up. We'll go into the emergency phone number after the break when we talk about the safety quiz. The lab cleanup policy, as you can see, these lab benches are super neat and tidy. The lab techs do a really great job here of keeping everything neat and clean for you guys. So just as common courtesy to them, to each other, and to the other students who use this lab, please clean up after yourselves when you're done. Really just put things back the way that they were when you got here. The one thing is that at the end of the day, I know it's late, everybody's got a bunch of components that they've taken down to build their lab, and there's a temptation just to take them and put them in a pile somewhere. But then the lab techs have to go through and sort them and put them back in the right bins. So we really appreciate it if you can just take the extra minute or so to sort everything out and put it right back in the bins where it came from. That way, it'll be there for everybody else who's using the lab, and it'll be there for you guys next time you come back and use it. Okay? So that's the lab cleanup policy. The equipment use policy, we let you guys use some really cool high-tech stuff here. So just don't abuse it. It's pretty bomb-proof, so you have to try really hard to mess it up. So as long as you don't try hard to mess it up, everything should be all right. Don't forget to log off and turn off the computers when you're done. Or just log off, I guess. Don't turn them off. The next steps. There are a bunch of certificates that you guys can earn with this class and others. I'm not going to go into all of those today because I've already, poured a bunch of information on you. But those are available. We'll talk about those in another day or so. Sometime soon, we'll go into all of those, but there are definitely some really cool certificates that you guys can earn. So, any questions about the next steps or stuff that we talked about so far?
No, we all know classes, right?
Right. There's no eating or drinking in the lab. We'll talk about that a little bit more later. So if you need to eat or have a drink, it's totally fine to just step out the door and have a quick snack or a drink or whatever you need. Just finish it outside and close it up and put it in your bag and come back. And that's what it comes. Okay. Other questions? Yeah.
You know when the overlap's going to be this semester?
It'll be starting in week 3 or so, and I believe it's Wednesday, Thursday, Friday, probably from 4:30 until 6 or so. That's what it usually is. That would be my best guess. So on to the course topics. There are many course topics listed out here. You guys are free to go through and read them all. I think we covered them earlier when we talked about how do you live and wondered, and also when we talked about student learning outcomes and stuff like that at the beginning. So I'm not going to go through and read every single one of these, but you are free to do that, and you can ask any questions if you'd like. So any questions about the syllabus in general? All right, then why don't we take a 10-minute break or so. We can come back, try and be back here around 7:15, and then we can go through and do the safety quiz and see you.
You know, you're lulling us all, making us seem like it's just gonna be smooth.
It's gonna be tough, don't get me wrong.
I know, that this first day when you've got to go through everything, it's
Oh,
like,
I
oh
know.
yeah, this is no problem.
Yeah, no, this is,
Until you reach about lab, I don't know, 3, 5, whichever one it is.
yeah. But I'll be there for you. If you get stuck on anything, I'll help.
I know. And of course, we'll have Earl.
Yep.